This is a practical guide to role engineering. Our session objectives: to gain understanding of the role-based access control standard, to learn the repeatable steps of the role engineering process, and we want to learn about using RBAC with the Apache Directory Fortress engine. My name is Sean McKinney. I am a systems architect with Simus, and I am a member of the Apache Directory project and also the OpenLDAP engineering team. The agenda: we'll define role engineering, we'll take a look at role-based access control standard in Sites 359, we'll examine the 5 steps of the role engineering process, I'll have a quick demo, we'll review some extra credit questions, and then we'll wrap it up. I received this definition off the internet from the Oracle blog, and it's about as good of a definition as any, so I'll read it to you. Role engineering is the process by which an organization develops, defines, enforces, and maintains role-based access control. RBAC is often seen as a way to improve security controls for access and authorization, as well as to enforce access policies such as segregation of duties to meet regulatory compliance. In order to understand where we are, it's important to understand how we got here. And a review of the history of role-based access control will show you that the model has been in use for decades. And it wasn't until the early 90s, with a team from National Institutes of Standards and Technology led by David Ferraiolo and Richard Kuhn, that the march towards standardization began. And the model, already in use for some time, was meant to fix problems with discretionary access control standard, which was the prevalent model in use back then. And in particular, DAC was not meeting the needs of non-Department of Defense organizations. Integrity was lacking, as defined by them, as a requirement for data in process to be modified only in authorized ways by authorized users. Integrity and access control. Keep those thoughts in mind as we continue this talk. Later, around 2000, they teamed with Ravi Sandhu and produced another influential paper called the NIST Model for Role-Based Access Control Toward a Unified Standard. And this really set the stage for the standardization work that followed, where the functional specifications were laid out in a formal notation known as Z notation, and the functional specifications left no ambiguity as to what the standard was supposed to do and how it was supposed to work. What we're left with today is 2 standards: Insights 359 2012, which is known as the core, and Insights 494 2012, which is RBAC Policy Enhanced. The core is really the one we're going to focus on today. That's the one that has the most traction. Insights 494, RBAC Policy Enhanced, shows promise, but it's not widely used today, so we will just discuss it. We won't be practicing it. Here is a copy of the specification, Insights 359. And it outlines security in 4 areas. RBAC zeros, known as the core, and that's the base that any system must have in order to be deemed RBAC compliant. And that's users, roles, permissions, and most important, sessions. Sessions are the context for which roles are activated. RBAC making the distinction between roles being assigned and roles being activated. And this is in keeping with the principle of least privilege. Only give the user the power they need to complete their job at any point in time and no more. RBAC 1, hierarchical roles, is more about administration, and it's designed to make things easier for the administrator. They can set up base roles that have base levels of permissions, and then have derived roles that are actually assigned to the users that inherit from this, and it keeps to a minimum the amount of roles that have to be created and helps to reduce role explosion problem. RBAC 2, static separation of duties, is how you apply mutual exclusion constraints between assigned roles. In RBAC 3, dynamic separation of duties is how you apply mutual exclusion constraints between activated roles. Again, the difference between assigned and activated roles being important in RBAC. And both of these are ways in which to eliminate toxic relationships between roles, which is to say that some roles taken together give the user too much power or produce the possibility of a conflict of interest. And so these kinds of things are meant to eliminate that problem. The object model is quite simple. The user is present in every system, and we know what that is. The role is a many-to-many mapping between users and permissions. And permission is a mapping between an object, which is a system resource like a page, file, or a table, and an operation, which is an executable image of a program, add, update, delete, or search. And then again, the session, which is the context for activated roles. The functional model has three standard interfaces, and these are the APIs. And this is bringing in some of the power of RBAC, is that the APIs are standardized. And the administrative APIs are how you insert data into the policy database. The review APIs are how you interrogate or report on the relationships. And the system is policy enforcement. That's what we usually think of when we think of a security system, are the policy enforcement APIs. Here's a peek at the admin APIs. Up at the top are the Apache Fortress version of them, and you can see at the bottom is a excerpt from the Z notation in the specification itself. Here it's for grant permission, and you can see the Z notation, which is a set theory type of representation of exactly what's supposed to be happening inside of this function during this call. And so, as I said, it removes any sort of ambiguity as to what's supposed to happen here. So all we had to do was to follow the specification, and then we know we've met the requirements that was supposed to be satisfied by the RBAC standard. Here are the review APIs, and there's many here that you probably never thought of, but this is how you would figure out what's already been set up. And again, we see the Z notation at the bottom for user permissions as compared to the functions in Apache Fortress at the top. And again, the names and the entities are exactly the same, which is why Apache Fortress is a reference implementation for ANSI RBAC. Usages for these two standard interfaces is, of course, you could build a user interface, you could generate reports to verify compliance, you could migrate from one security system to another. Indeed, it covers use cases you didn't even know you had. Specifically, as to looking at a few of these APIs and what they do, here we can see assigned users, which is given a role, return the list of users that have been assigned to that role. And here is authorized users, given a role, return not only the assigned users, but the users that may inherit from a role that has this role, which will be a larger data set. User permissions, given a user, return their permissions. And permission users, given a permission, return the users that have access to that permission. And this, sadly, is an example of an API that many access control systems can't actually achieve, which means that they lack integrity. Obviously, these APIs would be well driven via a user interface. Here we can see a screenshot of the Fortress Web, where it's doing a use case that we are going to examine later, which is given a permission with an object name of auction and an operation name of create, return the users that have been assigned, and you can see John Doe and R. Taylor's in the set returned. Implementations of RBAC admin and review, we have Apache Fortress REST and Apache Fortress Web. The system RBAC APIs, again, are the APIs we think of when we're trying to visualize in our mind what an access control system does. Here at the top, you can see this is the Fortress version of these APIs, and again, we tried to follow as close as we could to the specification. in terms of the operation and entity names. And at the bottom, you can see the Z notation for check access, which tells us exactly what that function is supposed to do in Z notation. A couple APIs from this interface. Check access, that is for a single permission, return if the user can do it, yes or no. And session permissions, given a user session, return all the permissions active at that time. The use case here is more of a user interface type of a scenario where you want to pull back all the permissions in the beginning and cache them in a map inside the user's HTTP session, and then check them as you go, cutting back on round trip times with the server. Implementations of RBAC system, we have Apache Fortress Realm and OpenLDAP Fortress Accelerator. That was the description of ANSI Insights 359. Hopefully that makes sense. We are going to be taking that, what we learned there, and applying it in the next section, which is the 5 steps of the role engineering process. The introduction, the role engineering process goes from a human understandable policy definition, i.e. security use case, to a format that may be loaded into an RBAC engine and used across a wide variety of apps and systems. What are we saying here? We are going from a policy as articulated by us, the humans, and we are going to refine it into a format that can then be loaded into a policy decision engine, and we are going to do all the steps that we need to do in order for our applications and systems to take advantage of that. The 5 steps defined, we have number 1, we're going to define security use cases. Number 2, we are going to derive those into entity lists. 3, we're going to convert that to a policy and load it into the RBAC engine. 4, we are going to add policy enforcement into the application. And 5, we are going to assign users to roles. Process participants, we have the usual suspects. You have the business team, and they are going to want to be the ones to define the security use cases and create security lists. We have the security team, and they want to load the RBAC engine. And you have the development team, and they're probably going to want to add the permission checks. And human resources usually are who assign users to roles. But you know what? It doesn't have to be that way. The business team might be wanting to take part in the user role assignment, and perhaps the security team wants to be the ones to create security lists. Regardless of how your participants take part in this process, your process must be flexible enough to accommodate. Okay, we are now looking at the security use case that will be in effect for the rest of this talk. This is a boiled down eBay. It's actually quite simple. That's by design. This step really is the hardest part of the whole process. This is this part that really this process can't help you that much with, because it really is all about you understanding the business to security process that has to be applied, and that there's no magic there. That just requires work and thinking about it. So we're just going to have this simple sort of auction website where we have buyers and sellers, and they do things like place bids and purchase items and ship items and things such as that. And as we just jump into these use cases, we're going to say use case 1, every user must authenticate before landing on the home page. This is, of course, the first use case for any set of security use cases. You always have an authentication step. Does not matter how that authentication took place. Could be a password check, could be a certificate, one-time password, multi-factor, single sign-on. Regardless, you're going to have to authenticate, and you're going to gather the roles and activate them into the session within an API that is called create session. Use case 2, we have a buyer, and they can place a bid and purchase items. So we can articulate that into a statement that says a user must be a buyer before placing a bid on an auction or purchasing an item. And furthermore, we can parse those elements into color coding to give us an idea of what type of RBAC entity we're talking about. For example, we have shaded in red the role, which is a buyer, and we have shaded in blue, which is the objects. We got auction and item, and shaded in green, we got the operations, bid, and purchase. So out of this, a role falls out of buyer and 2 permissions, auction, bid, and item purchase. Use case 3, we got sellers, and they can create auctions and ship items. So we can parse this into a statement that says a user must be a seller to create an auction or ship an item purchased. Turning those elements into RBAC entities, we have a new role called seller, and we have 2 permissions, auction create and item ship. Hopefully this makes sense to you. It's not meant to be complicated. It should be quite easy. It's really just a process refinement. The 4th use case, we have a generic user, and you can see they can create accounts and search for items. So this is telling us we have a base user, and then the other roles are going to inherit from that base role. And so we parse that into a statement that says all users may create an account and search items. So we have a new role called users and 2 new permissions, account create and item search. Use case 5, we're going to say only one of the buyer-seller role combination may be activated per session. So this is an RBAC dynamic separation of duty constraint. And we are going to parse that into a statement, say a particular user may be a buyer or a seller, but never both simultaneously. And that's it for step 1. We've defined the security use cases. Step 2, we are going to create the entity list. This is also just a process refinement based on the use cases. We're going to convert them into lists of entities. There's going to be 3 kinds of lists. We've got a list of roles, inheritance relationships, and separation of duty constraints. We've got a list of permissions, which is the mappings between objects and operations. We've got a list of perm grants, which is the mappings between the roles and permissions. So we've got here a list of role names, and that's just really collecting the roles that were defined in the use cases, users, buyers, and sellers. We've got the role inheritance relationships here. You can see that we've got 2 roles, buyer and sellers, and they both inherit from users. We've got the role activation constraints. This is the DSD from use case 5. And really all we're doing is creating a set name. We can call it whatever we want. We're going to call it here buy sell, and we're going to list the members, buyers and sellers. We're going to say the type, this is dynamic, and the cardinality. And the cardinality is 1 plus whatever the number is that can be activated. We're saying at most 1 can be activated, so cardinality is 2. List of permissions, we got 6. Item search, item bid, item purchase, item ship, auction create, and account create, and they just fell right out of the use cases from their previous step. And the perm grants, we've got 6 as well. We've got users that can search items and create accounts. We've got buyers that can bid items and purchase items. And we've got sellers that can ship items and create auctions. That's it. So we're on to step 3. We're going to load the policy, and that is to hand that list that was created before to the security team, and they're going to convert it into the particular syntax applied within your particular organization. Here, we're going to follow the Apache Fortress RBAC policy loading syntax. We start out with roles. We're just going to wrap it in a flat XML structure, and it really is just the list with XML. And role and inheritance, same thing. We're just wrapping the list we created on the previous step in an XML. And dynamic separation duty constraints, same thing. Permission objects, we've got 3. Item auction account. Permission operations, we've got 6. Permission grants, here we're going to combine all of those sets into a single file, and we're going to load it into the back-end system using a script, and it's going to produce an output like this. And the nice thing about scripting this is that you have a natural means in which to automate the policy load as your application or system evolves through the product lifecycle and runs from one environment to the next. It cuts down on the error-prone nature if from an administrator having to key this in manually. Step 4, we are going to add the RBAC policy enforcement points. This is the point in time where we have to wake up the programmers, and we're going to tell them to use RBAC system APIs for checking security and standardize on RBAC semantics, but don't standardize on a particular implementation. So use a facade and insulate your app from whatever the back-end system is, and in that way, as the implementation changes, you won't be severely impacting your app because presumably the model will stay the same. And as usual, favor declarative checking over programmatic, and what that means is declarative is programmer unaware. If you can engage the infrastructure to do these checks automatically, Try to do that to the extent possible. Keep in mind that as the granularity of the authorization check increases, then the likelihood of being able to use declarative checking decreases. Really what we're saying is somewhere in your application will be some application code that looks something like this, where you're gathering the RBAC session that was created in the beginning, and you're going to create a reference to a permission, which then maps to a particular resource operation you want to do, and you're going to call the System Manager API check access, which then returns a Boolean. Of course, you won't hard code your permission names. This is just for an example. If you want to look at some code that does this, you can look at number 3, which is the role engineering sample, which is the demo that I'm getting ready to show you, which is this actual use case. Or if you want a more complete coverage of end-to-end security tutorial, look at number 1, which is the Apache Fortress end-to-end security tutorial. Number 2, the Apache Fortress Wicket sample, is more about how do you integrate your Java web application with a system like Apache Fortress. So it's more about integration, not so much focusing on the how-to of security. And finally, number 4, the Apache Fortress SAML demo shows you how you can combine something like a SAML 2.0 authentication with a role-based access control authorization. All samples that are available for you to try out. I encourage you, if you have interest in this area, to take a look. Okay, that brings us to step 5. It's time to assign users to roles. And for us, this is our policy, which is a quite simple policy where we have 3 users. S. Smith has been assigned to the role of buyer, and R. Taylor has been assigned to the role of seller, and John Doe has been assigned to both roles. And we can describe that policy and record it into the access control engine using a script like before, like this, or probably more likely is you'll have a user that fires up a user interface, and they'll assign the role in something like this. And here we can see the user John Doe is being assigned the role of seller. That's it for the 5 steps. Hopefully that didn't seem too painful. And as way of summary, we have number 1, define security use cases. Number 2, we want to derive those into lists of RBAC entities. Number 3, we want to convert and load into the RBAC engine itself. Number 4, we are going to add security checking to the application. And 5, we are going to assign users to roles. Demo time. And I'm going to show you the role engineering sample that I talked about earlier. And that is really the use case that we just covered inside of a very simple Java web application that uses the Apache Wicket framework. And the system architecture is this application is running inside of a machine inside of my IaaS cloud, and that machine has 2 processes. Inside of it has Apache Tomcat with the role engineering sample deployed, and it has Apache directory server that has the LDAP where the policy resides. And then we have really 3 things going on from a security perspective. We've got Java EE security that's happening between the container and the app, and then we've got Spring security that's down inside the app, embedded into the app, and Apache Fortress programmatic checks are happening for the permission checks. As far as the architecture and where things are going on, we have at number 1 and 2, we've got declarative checking, which means programmer unaware, and that is Java EE authentication, coarse grain authorization, and Spring page level authorization. Number 3, we have RBAC permission checks. Those are programmatic, which means the programmer was engaged, and that is controlling the links and buttons. And then the 4th control is I have this RBAC dynamic separation duty checker that allows a user to switch from one role to the other. Here is the sample. It's in my GitHub repo. It's free for you to use and change how you need to. All the steps to get it going are listed there. So we're going to go ahead and fire it up because I've got it running inside of my cloud. Here is the GitHub app, by the way. And so this is where you'll start if you want to try this app out. I'm just going to open up the link to the sign-on page, and we're going to have a look at the policy. So speaking of the policy, we have S. Smith, who is a buyer, and we have J. Taylor, who is a seller, and we got John Doe, who's both. And that is going to create a problem because we have a dynamic separation of duty constraint violation with that. So we'll see how that's handled. And then this is perhaps where the rubber hits the road, which is what is the user to permission mapping. You can see S. Smith and R. Taylor have some limits in what they can do, whereas John Doe is able to do everything with the DSD constraint. So let's go ahead and sign on as S. Smith, who's a buyer, and we'll see what happens. So I'm going to go ahead and log in. This is the Java EE authentication that's controlling this, and S. Smith signs on, and they are a buyer, so they have the link to the buyer's page, and you can see that they have the users menu, which is, this is the base role that all other roles inherit. So the users menu gives them the ability to search items and create accounts, and so these permissions, these buttons are guarded by RBAC permissions. And then if they click on the buyer's page, then it takes them to the buyer's menu, and you can see they can bid on items and buy items like buyers can. When S. Smith tries to switch to seller, they get an authorization error because they haven't been assigned to that role, and they are limited to only being a buyer. So we're going to go ahead and log out as S. Smith, and we're going to log in as R. Taylor. And R. Taylor is a seller, and when they log in, you can see the link to the seller's page, and they too have the users menu, which all users get, which is the search and account create. And when this user clicks on the seller's page link, you can see that they are allowed into the seller's menu, and there are the permissions that correspond to that. If this user tries to switch to a buyer, they too will get an authorization error because they have not been assigned to that role. Let's log out as this user, and we'll log in as the third user, John Doe, who has been assigned to both roles. And when they log in, you can see that for whatever reason, they are just being held to being a buyer. And so we're going to have to figure out why that is. And you can see they too have the users menu, just as the others, and they can do the users things. So when they click on the buyer's page, then they are allowed to do the buyer stuff as well. Now, when this user, John Doe, clicks on the switch to the seller, you can see that they're actually allowed to do that because they have the seller role. And now the seller's page link pops up, but the buyer's page link disappears. And now this user can click on seller's page, and they can do seller things. So this user, while they can't be both at once, they can switch between one or the other. And that is in keeping with the principle of least privilege, in that they are limited to what they can do at a particular point in time. So that really is the demo. It's quite simple, just meant to illustrate those basic concepts, and you're free to try that out at home and to gain a deeper understanding. Speaking of deeper understanding, let's go a little bit further into RBAC and look at some more advanced topics. Question number 1, how do we get more attributes into the access control decision? With role-based access control, one of the complaints is that it is a role-centric model, and that it's hard to get constraints in there based on attributes like location and time and organization. And the answer is use ANSI Insights 494, which allows attribute modifiers. And have a look at this paper right here that compares RBAC and ABAC. It's written by Ed Coyne and Timothy Whale, and it really does go into the argument of which one's better, attribute-based or role-based. And the answer is there's no right answer. Everything's a trade-off. There's pros and cons for one versus the other. And really what this paper is about is how to get the best of both worlds, how to combine them. And so it's a really good paper, and it talks about how Insights 494 can be used to achieve a higher functioning access control decision engine. RBAC extra credit number 2, what happens when a user with conflicting roles tries to log on to the RBAC system? Well, didn't we just see that with our John Doe user? And the answer is yes, we did. And here's a look at what happens behind the scenes. So this is the system log when John Doe logs in. And what basically happened with the Fortress system is when it tries to activate the second role that would then violate the separation of duty constraint, it just tosses the second role and logs a warning. So the application can then mine the warnings when the session returns and respond in such a way that they deem necessary. This is not behavior that's rigid by the specification. This is really, RBAC allows the application to decide what they do when a violation occurs. Perhaps you'd want to just fail the session and have the user not even be able to log in at all. That's application-specific behavior. And whereas Fortress tries to degrade gracefully and just tosses any of the violating roles and then logs in as warnings, perhaps your system has other kinds of requirements. RBAC extra credit number 3A, how do we prevent someone from being assigned multiple roles simultaneously? And that would be, we just take the same set from before and we just make the set type static instead of dynamic. And now when the user tries to, when the user is assigned a role that violates that constraint, then it will fail at assignment. So the user won't be allowed to be assigned both those roles. RBAC extra credit number 4, role-to-role static separation duties is just too simple to work. It only works at the role level, and the toxic relationships are always between permissions. This is a true statement. A simple use case will illustrate what I'm talking about here. We have 2 permissions that are toxic. We'll call one permission A, we'll call the other permission B. Why they're toxic, it doesn't matter, but basically the idea here is that those 2 permissions should never be allowed for a single user at the same time. And so we create 2 roles that each are granted to their corresponding permission. So we have role A that's been that has permission A granted, and we have role B that has permission B granted. Okay, good so far. And then we apply a separation of duty constraint between role A and role B so that the combination can't be realized either statically or dynamically. It doesn't matter which one. Either way, the use case is valid. The problem is nothing in the specification prevents an administrator from creating a 3rd role, say role C, that then directly grants those 2 permissions directly, permissions A and B, thus sidestepping the separation duty constraint. So that is indeed the problem. That is a real scenario, and it's valid. So the short answer is use Insights 494. RBAC Policy Enhanced has a section 5.4.2.2. Permission to permission static specifically deals with this use case. Or the longer answer is, if you're stuck in an Insights 359 world, then never assign roles that have toxic permissions directly to users. Always use inherited roles with RBAC 1. And so what I'm saying here is establish a convention that works around the problem. Not an ideal solution, but it should work if you're careful. RBAC extra credit number 5. This session's use case was far too simple. Can we do something more realistic using RBAC? The answer is, well, yes, of course you can. You can have a look at the Apache Fortress end-to-end security tutorial, which has more complicated use cases and more roles in the mix. Perhaps you could say that's role explosion. But yes, there is much more complicated use cases that can be supported. RBAC extra credit number 6. To adequately model my organization's security using RBAC will cause role explosion. What am I to do about that? Our roles are exploding. Our machines are in tatters. We've got a messed up data center. Everything's messed up. My boss is mad at me. What am I going to do? The answer is, well, sucks to be you. You know, really, there's no free lunch here. There's no magic. So those relationships, whatever they are, they've got to reside somewhere. And if you don't want them to reside in your RBAC engine, then you're just gonna put them somewhere else. And there's no magic here. There's no silver bullet. That's it for me. Closing thoughts: using roles for access control is not the same as role-based access control. Just because you've got some sort of check in your application that's doing an is user in role, that's not RBAC. RBAC is a permission-based semantic with sessions and constraints and things like that. So correspondingly, Insights 359 is more than just access control APIs. It's got the model for functional, it's got the model for object, it's got the APIs, it's got other things. And so the true value of an Insights 359 is everything collectively. You can't take just individual pieces of that model and expect to have the full value of the specification. You need the whole thing in order to get all the value. And finally, I'll say all applications need at least RBAC. RBAC will not satisfy all the requirements for all your applications. It's not a panacea, but all apps need at least that, and then you build on that for the missing pieces. The tutorial links, the role engineering sample, again, is in my GitHub account, or take a look at the end-to-end security tutorial, which goes much deeper in terms of the security prescription. Finally, I'm out there. If you have any questions, if you think I'm crazy, you may contact me and let me know why. I'd love to hear from you. I learn from you.